This is the usual QGIS project layout. It has a layer panel, a browser panel, a map canvas, menu bars, title bar and status bar with coordinate box for mouse pointer location, and also the coordinate reference system among other status. Notice that in the layers panel 2 layers are checked, but only one layer is visible on the map canvas. The overlaying layer is the one that is visible, and we can view the underlying layer on the map canvas by unchecking the overlaying layer. Then when it's rechecked, it is hidden again, the underlying layer. This layer, this project rather, is different to the poster project because it contains an orthomosaic base map. The orthomosaic was created by the drone as shown here, an RTK drone with a base station. The mission for the drone was automated by the drone software subsequent to an area and altitude being selected by the operator. 293 photos were taken at an altitude of 24 meters. Note that the later orthomosaic ran the same mission exactly. The software used to stitch the photos that the drone took is a subscription software called Metashape, which completely automates the process and produces the orthomosaic, an image 9,320 by 25,155 pixels in size, and a ground sampling distance of 5.95 mm per pixel as recorded by the Metashape software. Note how the coordinates change as we move around the orthomosaic in the coordinate box. Notice also that we can use a measuring tool in the menu bar to measure the area of the fenced exclosure. So we choose a new measurement and we then mark out the polygon that we wish to measure the area of. And we can read off the area as almost 1 hectare. Note that the other orthomosaic that was taken a month later, the underlying layer, will have the same area when measured on the map canvas. Always remember to return to the navigation icon after using one of the tools in the map canvas. We can zoom in and out with our mouse scroll wheel. And we can drag the orthomosaic from side to side if we hold down the left button of the mouse. Also, we can return to the original size by right-clicking on the layer highlighted, zoom to layer. Now here we have the layer panel again, and this time I want to show you how when we hover the mouse over it, we obtain the path for the underlying file for that layer. When we read that pop up, we can then go to the browser panel, go through the tree media barrier expansion, and then ortho 2024-0420.tiff, which then is the position within the computer file structure to find the underlying file that supports that layer. Now the rest of the layers in the layer panel are LandDrone layers as per the project, poster project. Here we can see the 4 different fieldwork events by the LandDrone for the front camera covering the whole hectare, and similarly 4 fieldwork events for the rear camera covering the whole hectare. Now let's look in more depth then at one of the layers. If we right click the layer, we get an interactive menu, and you can zoom to the layer. You can now when you right click on the interactive menu, it depends where you right click. If you right click in the browser panel, you get a different pop-up menu, interactive menu, to if you right click in the layers panel. So the layers have labels which you can toggle on and off. The layers also have their own table called the attribute table. Now the attribute table, as per the project, has different columns and rows. Here we can see the rows of the table and the columns. There are 5 fields in this particular project, and when you toggle the table, you get a different view, which is just one row view compared to a whole table view. So we'll use the one feature view for the table and investigate this a bit more. Now there are 5 columns in the table, 328 rows. If we choose the first feature or the first row, it highlights on the map canvas if you highlight it within the attribute table with the yellow square. So now also we can click on the link to the video segment that relates to that particular location. If we now go to the last location in that fieldwork event, second last location in that fieldwork event, and we can make the icon blink, and here we have the video for that second last point in that fieldwork event or segment, video segment. The data analyst will often find a point of interest where they might want a still image of a germinant or a particular species in the project. Here we are monitoring an intermittent ephemeral soak, and a number of species which were missing from the plant assemblage were planted at the beginning of the project, one being Leptospermum continenale, or prickly tea tree. We can zoom in to find whereabouts the prickly tea tree was planted, and then highlight the layer that has taken video of that particular location. Point 209 is the one that seems in the middle of those prickly tea tree plantings. So we will get the video segment for that point by copying the link and then transferring that path to the video editing software. So first of all, we want to copy the path into a text document so we know exactly what the path is. Then we can refer to it to open the video editor, which is a different program, so that we can extract the frame of interest of the prickly tea tree. Highlight that particular file, then we have the segment coming up in the video editor, and now we can step through the segment frame by frame until we find a suitable frame for us to have a careful look at. Once we have found the frame, we can then extract the image of that frame. By clicking on the icon at the bottom right in the lossless cut video editing software, and now we can show the JPEG image file that has been created from the video segment in a normal photo display software. So find the JPEG file, double click, and here's the JPEG file. We can see the nuts that the prickly tea tree has formed following its initial planting.